Honors Algebra, Mr. Lawrence here with your flipped lesson. I think today is Wednesday, May 2nd, 2 days before National Star Wars Day. Oh boy, I'm so excited. I get to say May the 4th be with you. Anyway, we've got a quiz tomorrow, right? And I thought I'd do a couple practice problems to help you get ready for your quiz. Okay. First of all, we have a simple subtraction problem of rational expressions. Before I go looking for the LCD, first thing I'm going to do is I'm going to factor the denominator of the first fraction. I notice that's the difference of perfect squares. It'll factor as a plus 2 as a quantity times a minus 2 as a quantity. All right, now I can go looking for my LCD. All right, my LCD. I need one factor that has to be in my LCD. Well, I have to have an a plus 2, a quantity of a plus 2. And remember, when that quantity, when I write it under the LCD part over there, I can underline it once in the denominator of every fraction. So that is part of my LCD. That is one of the factors of the LCD. All right, the other, I don't have my complete LCD yet because this factor of a minus 2 as a quantity is not accounted for. So I'll put him over there. I've accounted for everything. So the question is, what am I going to do to this first fraction? Well, this first fraction is 3a over a plus 2, a minus 2, both as quantities. And the answer is I'm not going to do anything to it. It has the LCD already. I'm not going to do anything to it. The second fraction, however, does not have the complete LCD. It has one of the factors, but it's missing the other one. I'm going to multiply it by a very special form of 1 using the factor that it does not have. When I do this, now I end up with 3a minus 2a plus 4 in my numerator over the LCD. Now some of you are going, wait a minute, Mr. Lawrence, how did you get plus 4 there? This negative belongs to the whole numerator. So what I did in effect was I just made that 2 negative and then I distributed the negative 2. Okay, so I changed the problem to addition and then made the 2 negative. Some of you would have seen that in elementary school where you have 5 minus 3, or you could write it as 5 plus negative 3. All right, some people call it like a leave change opposite or something like that. Okay, anyway, so back to our problem here. I'm going to simplify my numerator and I'm going to get a plus 4 over the quantity of a plus 2 times the quantity of a minus 2. All right, and I'm going to state my restrictions. And remember, I want to do my restrictions from the beginning of the problem because if anything has simplified and canceled out, I will miss them. And it looks like a cannot be plus or minus 2. And there you go. All right. Now, multiplication and division, I think, are easier. Of course, I love factoring, so that's what makes them so simple. So, my first fraction is y plus 5 over the quantity of y plus 4 times the quantity of y minus 4. How come? Because I factored this guy as the difference of perfect squares. I need to multiply that by, let me see, that's a perfect square trinomial. I need 2 factors of 8 that add to get 6. 4 and 2. Y plus 2, y plus 4. The denominator, I need 2 factors of 15 that subtract to get positive 2. Sounds like a y minus 5 and a y plus a 3. And now I'm going to look to simplify, and I'm going to check 4 directions. I'm going to check this way, I'm going to check that way, and I'm going to check diagonally. All right, and I notice right away that I have a y plus 4 and a y plus 4. Those will cancel, right? I don't see anything else that's going to simplify. I've got a y minus 5 here, excuse me, a y plus 5 and a y minus 5 here, but that's not the same. So they don't simplify. So I get this as my numerator and this as my denominator. Now, if you're a glutton for punishment or just really love math and you want to FOIL and distribute and do all that, you can, but you can also stop here because that is in simplest form and it is obvious to the reader that it is in simplest form. Don't forget to state your restrictions, and I'm going to do my restrictions from this line before I crossed out in red, or in blue, before I crossed out. So I see that y cannot be -4, cannot be +4, cannot be +5, cannot be -3. So -3, 5, and plus or minus 4. If I make y any of those numbers, my denominator turns to 0, and I can't do the problem. All right, last problem, division. It's the same thing as multiplication, except you have to remember to multiply by the reciprocal. So this first fraction, I'm going to factor and get a y minus 1. That's my numerator. This one I'm going to pull out a GCF, a y, but when I do that, I'm going to get y squared minus 4. And this is the difference of perfect squares, so the denominator is going to look like this. Oops. All right. I'm going to change it to multiplication, and now I've got to flip this fraction, use the reciprocal. All right, to do that, I'm just going to kind of do it in one step. I'm going to factor this guy, but I'm going to write his factors in the denominator. He looks like a perfect square trinomial to me, so he'll factor like that. Now this one here, I need 2 factors of 6 that add to get 5. Well, y plus 2 and y plus 3. Now I'm ready to simplify. All right, I've got a y plus 2 and a y plus 2. I've got a y minus 1 and a y minus 1. I've got a y and a y. Notice in this problem I simplified this way, and that way. I looked here, this direction, but there's nothing that'll simplify vertically in the second fraction. So now I'm ready to multiply my numerator. The only thing left is a y plus 3. My denominator, I still have a quantity of y minus 2 and a quantity of y minus 1. And again, if you want to FOIL that out, it's not wrong, but I love this answer because I can tell that it's in simplest form. All right, now, got to be tricky on this, got to be careful on this one. In this first fraction, I know for a fact that y can't be 0, and it can't be plus or minus 2. -2 there, +2 there. Now if I look here, I also get the impression that y can't be 1, and I agree with that. But remember, this fraction flipped, and so I also have to check what makes these 0, because these used to be in the denominator. Well, -2 is already mentioned, so I don't have to mention it again, and then a -3. So there's actually potential for lots of restrictions when you're dealing with division problems, because you have to use the reciprocal. All right, Mr. Lawrence signing off. Have a good night, everybody, and good luck on your quiz.